Hello, everybody. This is Dr. Tracy Tooth with EEE145. I want to make a little demonstrational video for Lab 4 with the motor starting techniques because it's pretty complicated, right? So let me go ahead and get right to the chase and share my screen. So we're going to be here. So this is ETAP 21.02. And again, we're going to kind of show you how to do both static and dynamic motor starting. So first thing I would do if I were you is go ahead and download the Lab 4 document. It's going to have step-by-step on how to do the fault motor starting. I'm going to assume you already built the one-line diagram and you already did the load flow and fault analysis. So the transformer, bus, everything is set up. Okay, we're going to go literally step-by-step so I could visually explain to you what each step does. Okay, so first thing we want to do, we start by selecting the motor accelerator window. That's going to be this thing right here. Okay, so again, another kind of module we can use. So let's say you're at fault analysis first, which is this lightning bolt. 2 steps over, we do motor acceleration. Okay, so now we're in motor acceleration screen. So here, first thing we need to do is we need to double click the induction motor and make sure all the settings are correct. You should already put your nameplate data here before. Right, I choose a 500 horsepower motor. I believe you guys are using a 1,000 horsepower motor, right? I will go ahead with first thing. Actually, you know what? Let's go ahead and delete this. And let's start new. All right, so let's start with a fresh motor. Okay. So let's go ahead and do induction motor here. That way, your screen will look exactly like my screen. Let's go ahead and open it. Nameplate, library. 2.4 kV. I'm going to do 500 horsepower motor. Okay, so it's going to fill out everything. Don't care. The impedance model is already filled out. And this is the basics, all you need to do for fault analysis. Next thing we need to do is go to the load tab. Right, we're going to do static starting. So we need to make sure we can tell it what time does the load start. It's going to start at 0 and it's going to start at 0 seconds and we'll go to 4 seconds. Okay, so and again under loading tab. First thing we need to do is start acceleration time for static starting load 0 to 4. Click OK. Next thing we need to do is we need to go again to our dynamic our motor acceleration tab. We can't run anything yet on the right hand side. We got to go and build a case. So up here at the top a little bit, right there, you see a little bookcase or the suitcase. That is your editor for your study. So we're going to click this, and this is only here for the motor acceleration. So I think I had some things that were previously deleted. That's perfectly fine. So you're going to create a study case, motor start, right? All this, you kind of want to make sure just, this is all pre-generated. Don't worry about it. Big thing is you want to go to event. You're going to have to add an event. I already added one, so go click edit. So here you want to make sure you name it. You want to have a start time. I'm going to say 0.5 is when we're going to start. You want to make sure your simulation time is 6 seconds right here. Again, you can make this bigger or smaller if you want. We want to add an action. So basically, you're programming ETAP what to do. So I want a motor start. I want to add this motor start. Motor's going to start at 0.5 seconds. We got to select motor. Where action is to start it, and which one we're going to do. We're going to do motor 10. That's one I have selected. Okay, normal starting category. Click OK. So now when we run analysis, motor 10 is going to start at 0.5 seconds. Okay, I think that's all we need there. Let's double check. Yes. So click OK. Come back to the screen. Go ahead and click the second button to the right called Run Static Motor. See right here, Run Static Motor Start, and you click it. Right, you're going to get this little window that pops up to build it. Sometimes you're going to get an error and you pretty much just ignore it. Let's see if I could try to force an error. So you see this little error 2003. I honestly don't know what it is. I cancel it, try again. I might get it a second or third time, but you know, if you just keep on trying, see I got it twice in a row, to keep on trying, you're going to get it through eventually. Okay, so now you have the motors. It did its analysis. You got this little bar that goes 0 to 6 seconds. You can literally tab across it and you see right where you hit the 0.6 seconds. Notice we have 667 amps flowing in the motor. So now we know that the motor started. Okay, now we need to get a graphical event report coming out. So on the right hand side, these are the buttons we use to play around with for the motor starting. we want to go down to this motor starting plot. So we're going to draw a graph. So you go ahead and click the graph right here, right? So I will go ahead and close all plots. And then just to reset everything, click motor down here. So the device name, make sure you select motor, device ID, make sure you select your motor. And if all of these are checked off, you need to uncheck them. So uncheck them all, click the motor and click current, okay? And then make sure these are selected. If it's not like this and you click OK, actually it isn't working. So let me go back real quick just to double check. Motor 10, current, we're okay, right? So this is a graph that comes out, and notice you can see kind of like a little square wave. You could tell that the motor started at about 0.5 seconds, right? It went to a certain percentage full load amps. And then after about 4.5 seconds, the motor finished starting, and now we're at 100% full load amps. So this is kind of just like a very static, AKA boxy way to show motor starting, right? So which does work, but it's very not much detail. So this would be one part you can ask answer some quiz questions on for the static motor starting. Okay, so now let's go ahead and do dynamic one. So let's go ahead and get out of this one. We don't need that anymore. So now we're going to do dynamic motor starting. So if you go ahead and just start it right now, they probably just give you a bunch of errors that you don't have the extra information set. Don't worry about that. Let's go ahead and open up the motors tab. We're going to have to put in starting curves and impedances, all this extra stuff, right? We need to put the dynamic models in. So first thing is on these tabs, go to this model right here. So under models tab, we have a choice to use a circuit model or a characteristic model. Typically motors nowadays, they give you a slip chart, which will pretty much be a giant spreadsheet to tell you at what % slip the motor's acting. So we can get some pre-generated stuff there. So click the library button here, right? For us, I think for you guys, you're going to use 1,000 horsepower one. We're going to do the high voltage, high start, high torque. Model ID, you guys use 1,000. I'm gonna use 500 because I'm using a 500 motor, a 500 horsepower motor. It's gonna change kind of the lock rotor and some of the slips and whatnot because you're getting a more realistic model than just standard numbers. You should populate some graphs to show you kind of what this torque is going to look like. Look at your torque versus slip, so you can see as your motor starts, your torque increases. Look at your current is high, and then it kind of peters levels off as you get fully loaded, which is very common for a motor. So that's done. The next thing we need to do is we need to tell the program what the inertia is of the motor, right? When you start a motor, there's a lot of inertia you have to build up, so you have to tell them what to do, right? I think for you guys, you use 450 and 200, right? So this is kind of like telling what's the loading for that particular model and conditions, right? I'm going to just go ahead and just start play around with some numbers. Let's load this up pretty bad. 200, let's do 300, 40 and 150. So that's pretty heavy. The motor might not even start, but that's fine. If we get some errors, we'll come back and play around this. But this is where people get mucked up a little bit. You kind of just got to figure out what some decent numbers are, right? So then we go to loading. So we told the inertia of the motor and the coupling and the load. We told it what the startup model of the motor is. Now we need to give it the load model. So here you're going to go ahead and click the under load tab where you had a 0 to 4 acceleration seconds. Click this load model library right here. And we could choose generic loads and it will kind of base it off. I think you guys are going to use this compressor, right? A centrifugal compressor, aka turbocharger. I'm going to go ahead and use a fan, right? So think of like an industrial fan. So you see the loading is a little bit different. So we'll see what happens. So basically to recap, make sure you got your model here, characteristic model, your inertia, your load. If you look at your nameplate, it might have changed a little bit from what it was before because we loaded up a more realistic model. Okay. So click OK, cross your fingers, hope and pray. So hey, it ran first time. Look at that. Okay. So again, you might get some errors. Let's try to do it again. You see how you get the same error, just ignore it and keep on going. Okay. So here you get some motor starting. Let's go ahead and look at the motor. Do motor 10. Notice this time we could have speed, slip, and all this extra stuff because we have a dynamic model. So let's just look at speed and current. Okay, so click OK. So you see here, look at my current, my current. You have high current, and as a motor spins up, notice the current kind of lowers, settles down to more of a standard load, full load amp type of current. Notice our motor speed. It starts at 0, which is the standstill, and as it ramps up from 0 to like, what is it, 4.5 seconds here, your current's pretty high, but as it speeds up, current slows down. This is very typical of a dynamic motor starting curve. Okay, so, and then we could go back, and if you want, we could play around with inertia. We could load it up even more, which will probably bog it down. So let's do like 400, 50, 200, right? Let's run the motor analysis again. Nope. Go away, error. All right, so let's go ahead and check that plot. So motor speed characteristic. So you see this time, look, it took so long to start, it's off the charts. Okay. We could go the opposite way and we could unload the motor. So we'll only have like 50, 10, 30, and we might not even see it's going to, the motor's going to shoot up, the load is going to shoot up so fast because the motor is vastly more powerful than what the load needs to be. So, but we could see the graph just to give you an idea. Okay. So let's go ahead and speed current line, click OK. So you see how quick it was, like literally like less than a second or maybe 1 second, the motor just spun it up real quick. Okay. So in this case, what happens is the motor is way more powerful than what the load should be. So we kind of oversize it, kind of giant waste of money, but just to just show you how the inertia plays with your graph. So your graph should look something with this little hump you should see. Okay. That's what you expect. So why don't you, so for the lab, go ahead and kind of redo what I just did, put your own numbers that are in the lab manual and try to get those graphs out, analyze the graphs and answer the quiz questions. Okay, so hopefully this is kind of like a quick show of maybe like what, 5 or 10 minutes of how to do a dynamic motor acceleration analysis. Okay, so thank you for watching. Good luck in the lab. And if you guys have any questions, you know my email, and we'll see you there. Okay, thank you. Bye. So stop and